Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 357. Count numbers with unique digits. Given an integer n, return the count of all numbers with unique digits that are ranges from 0 to the given value. Power n. Sorry, given value in the power and 10 power n. Like that. Okay. Just see here. This is the example. See here. So n is equal to 2. So we want to say from 0 to 100, what are the unique values? See here, these are the duplicates values I can say. Yes, how many duplicates value there are? That 9. So 100 minus 9 is equal to what? 91. So 91 should be my answer. Fine. And then see this example. N is equal to 0. So for 0, I can take only 0. So my answer will be what? 1. So this is what a question. And in this question, see here, what they are stating, if I took 1, then I cannot take 1. Okay. If I take 2, then I cannot take 2 again. So it is something like pick and not pick in combinations, right? Combination. So I can say this is what a combination problem. So we want to draw a recursion tree, right? So let me draw the recursion tree. First of all, what are the possible combinations we can have? 0 up to 9. We can have values from 0 up to 9, right? Okay, let me draw up to 3 and consider this as up to 9. Fine. Okay, for the 0, again I can have from where? From 0 to up to 9, right? The 0 can have like this. Okay, but there is a contradiction, right? What is a contradiction? Just think about it. If I have 0 and if I choose 7, okay, which is equal to what? 7 only. But 7 is occurred at where? At this level itself, right? What is this level? This level is n is equal to 1 because all digits are single digit. So at this level itself, there occurs a 7 between this, right? So I can say I cannot take the 0 at the first level, right? So I can say when level is equal to 0 and also the value is equal to 0, I don't go beyond this. I don't go beyond this. I will take from what? Take from this one itself. From this one itself. Okay, I don't take this recursion call. Okay, from this one, I can say I can go from what? 0, 1, then 2, then 3 and 4 up to what? Up to 9. Okay, here comes a situation. See here, 0 is okay. 0 is okay. So which leads to what? 1 0. So here n is what? N is 2 at this level because we are taking what? 2 digits. Okay. Now 1 1. So which means 1 1. So it is repeated, right? So we don't want to take it. So to keep track on it, we can use a visited array or we can also use visited set. So what I am going to say is we can use a set or else we can use an array of length what? Of length 10, whose index consists of this 0th index consists of 0 count. First index consists of first and 3, then 4, 5, 6, 7, 8, 9 up to this. Then just mark it as everything as 0 initially. Whenever we are taking element, we will mark this as 1 so that I can identify that it is taken already or it is not taken, like that. So I cannot take this 1. So I will skip this iteration and I will take this 2. So 1, 2 will be my another answer. Okay, I can take this 3 again. Yes. This 4 again. Yes, like that. Can I understand this? Yes. Okay. So what is going to be my function parameters? It is going to be the length. The length. Also, we are going to take what? Take that current number. Like whether this 1 or 0 like that. Or you don't want to take it also. You can take what? This visitor array alone. So we can take the visitor array. In Python, we don't want to put this also, right? Can I understand this? So we want to take only what? The length in our function in Python. I will show you the code so that it will be more clear. See here. Now see here. Def combination of L comma num. So this is the first method I have done. Like we are taking the digits upon. Like that. I will tell you this method and also I will tell the next method also. See here. Then I am checking whether the length is equal to n. If it is equal to n, I will return what? 0. I will return what? 0. Now result is equal to 0 for val in range of 0, 10, which means I am taking from range of 0 to 9. Then I am checking whether the value is 0 and also the length is starting now only, which means what? Whether we have a leading 0. No, we cannot have a leading 0, right? So I will continue. Else I want to check whether that current value is present in visited. If it is not present in visited, then I can proceed further. Okay, I will proceed further and I will add in my visited set. Here I use set. You can also use the array, visited array also. Okay. Now result plus equal to, I can take this as a 1 combination. I took now I have a 1 combination, right? See here if n is equal to 2, I don't only take the length of 2, I can take what? Length of 1 also, right? So that only I am using what? Plus 1 here. Okay, and L plus 1, I am taking the next digit. Next time I will take the next digit, right? So I will make the length as plus 1. Now num into 10 plus val, which carries what? The value, the current digit. If 1, now it comes 2, then 1 into 10 plus 2, which is equal to 12, like that. We don't want to put this, right? So in next method I don't put this. Instead of I will take this entirely. I will show you that also. See here, v dot remove of val. Okay, now at last I am returning the result. Okay, v is equal to set of. Now I am returning what? Combination of 0, 0 plus 1. Okay, why I am putting this plus 1? Because just observe, in first iteration itself we occur as 0 and we are what? Continuing it. So that 0 can also be my answer, right? Can also be a part of my answer, right? So I will include that in here, plus 1. Let me submit it. Yes, it is submitted successfully. Now see the next method. Here I don't even include that number. I just include what? The length alone. See here, I just include the length. Other than that, it is same code. See here, I don't want to take that number. If they are asking that number also, you should take like that, right? So that only I showed that above approach. Okay, now other than that, it is similar to that. Okay, let me submit it. Yes, it is submitted successfully. Now let us talk about the time complexity. I want to tell you the time complexity. See here. Now what is the time complexity for this approach? I can say my time complexity for this approach will be O of something like, we are taking what? All 10, right? For one value we are picking what? 10 values. So I can say 10 power n. Can you understand this? Just observe. For one value I can pick what? For this one I can pick up to what? I can pick up to or I can select up to 10 values, right? So it is 10 power n. And also, what is my space complexity? I can say it is gonna be O of n. You may ask, it is so huge, 10 power n, but it is only n. Why? Because see here, don't ever forget, recursion is always what? DFS. It is not a BFS. It is not a BFS. It is only a DFS solution. Okay, so recursion will occur like DFS. So I will take this recursion path. Then after completing this only I backtrack. Then only I take this recursion path. So at most I can have how many recursion stack in my internal stack? I can have at most n. So n is the value they have given, like here it is 2 or 3, like that. Okay, it don't exit 8, right? That's what a constraint. Okay, fine. So this is my time and space complexity. Now it is so huge, right? We want to optimize it. Okay, how can we optimize it? Whether we have a better approach. Okay, let us think about the optimization. Okay, tell me something. It is like a permutation and plus combination, right? It is like combination plus permutation. Fine. In these methods, what we are going to do, we are going to select and we want to calculate how many ways we can place. How many ways we can place, right? So this is gonna be our mindset. Fine. So I can say if the n value is 1, take for example n value is 1. Okay, now how many elements I can pick? I can say I can take what? From 0 to 9, which is equal to what? 10 elements. So when n is equal to 1, I can take from 0 to 9, which is equal to 10, right? Okay, for n is equal to 2, for 2 I can take a 2-digit number, and I can say here I cannot take 0 to 9, right? Whether I can take here 0 to 9? No, I can take from 1 to 9 because of leading 0. Okay, I cannot take. Okay, here what are the possible values I can take? I can take from 0 to 9, but here I took one thing, right? Here I took one number. So here I can take what? 0 to 9, but I cannot take that number which is picked in the previous digit. Okay, which means, see here, which is equal to, here I can pick what? 9 possibility, 9 ways, into here I can pick what? Another 9. Here what? 1 to 9. In 1 to 9 we have 9 digits. I can pick only one. Here I have 0 to 9, 10 numbers, 10 possible numbers, but already one number is picked. So it is 10 minus 1, 9. So which is equal to 81. Can you understand this? Okay, now going to the next value, n is equal to 3. So I can say 3 digits will be there. Here I can pick what? 9 possibility. Here also I can pick what? 9 possibility. Okay. Here also I can pick what? 0 to 9 only. So already I pick 2 values. So I have only 8 possibility. So it will be something like 9 into 9 into 8. Yes. Okay. If n is equal to 4, what is my possibility? 1, 2, 3, 4. So here also 9. Here also 9. I can pick 8. Here I pick 7, right? So 9 into 9 into 8 into 7. So this is the formula for finding the number of ways, right? In permutation, we will find like this. So see here, I can place 9 value, 8 value. But how come 7 here? Because I placed already 3 values. So 10 minus 3 is equal to 7. Hope you understand this, right? Okay. If n value is 5, try by yourself. What is the value? 9, 9, 8, 7. Here 6, because we have took 4 values already. So it will be something like 9 into 9 into 8 into 7 into 6, right? So calculate this. It is huge value. Let me open the calculator also. Okay. If they are asking us to find whether n is equal to, take for example, it is 3. Okay. N is equal to 3. Take for example. So I can say n is equal to 1. 1 digit is also included. Plus n is equal to 2 digit is also included. N is equal to 3. 3 digits is also included, right? So what is the 1 digit number? It is 10. Okay, we include this. What is the possibility of 2 digit number with unique digits? It is 81. Okay. What is the possibility of 3 digit number? It is 81 into 8, right? So it is 648. So this is also a possibility. So just add it. So 648 plus 81 plus 10. So plus 81 plus 10. So my answer will be what? Something like 739. So this is gonna be my answer. Can you understand this? Yes. If they ask for n is equal to 4, if they ask for n is equal to 4, then you should add what? 4 plus 3 plus 2 plus 1. These are all things. So 10, 81, 648, and this multiplier also. Now hope you understand this approach, right? Okay. Let us see the code so that it will be more clear. See here. Let me comment this. Fine. Now see here. D is equal to R is equal to 9. Initially I am taking 2 variables. Wait, I will tell you what are those 2 values. I will tell. Wait. Now result is equal to 10. What this result signifies? This is the initial value. Initial value if n is equal to 1. Okay. Now if n is equal to 0, I can take a 0 as my answer, right? So I will return 1 as a base case. Okay. Now sorry, edge case. It is not a base case. It is edge case. For I in range of n minus 1, which means what? I am iterating from what? 1 step ahead, because I took what result as 10, right? I took result as what? 10. So for 1 digit number I can have 10 possibility. So I took already this 10 such that I am just going to iterate what? For n minus 1 times. Okay. Now R is equal to R into D, which means just take for example, first of all R value will be what? 9, right? What is the D value? It is also 9. So I will multiply 9 into 9. Then 9 into 9 will be stored in 1, and I will multiply with what? 8, such that 9 into 9 into 8. Then I will store in that in a R. Then again into 7, which means what? 9 into 9 into 9. Sorry, 9 into 9 into 8 into 7, like that. Can you understand this? So R will be hold my value like, see here, R. Let me take any other color. Okay, R will be going to hold my value like, first it holds what? 9. First it holds what? Let me take here. It holds what? This 9. Okay. Then it holds value what? 81, which means these 2 values. Then it holds what? These 3 values. Then it holds what? These 4 values, like that. So these are all what? R value. R will hold these values, and D will be reducing one by one time. So this will be D. Can you understand? It is quite tougher to implement in code. This R, this D, and this R. Quite tougher to implement this code, but you have to know, right? So that it will be more easier to write this rather than the backtracking approach, right? Okay, see here. In every time I will do what? D minus equal to 1. I done there also, right? First it will be 9, then 8, then 7, then 6, then 5, like that. Okay. Now result plus equal to R. Why I am doing result plus equal to R? See here. First I find 10. I will add this 10 and this 81. Then I will add this with what? This 648. Then I will add to this result. Then I will add this to this result. I already told you, if it is 3-digit numbers, then I can say 1-digit number is also possible, 2-digit number is also possible, 3-digit number is also possible. So we want to take all number combinations, right? So that's why I will add it. So my result will add each and every time. Okay, I will return the result. Can you understand? Very tricky, right? So this is what a math approach. Let me submit it. This is how the math approaches are. It is like how many possible ways we can place each and every time, everything. So it is submitted successfully. Now it's time to see the time complexity. It is so simple, right? What is the time complexity? It is gonna be like O of n. And what is the space complexity? It is gonna be like O of 1, because I haven't took any auxiliary space. Now compare these two things. It is O of n and it is O of 10 power n. It is O of n and it is O of 10 power n. So from this you can understand, if the question is about the count, we don't want to focus in everything. We only focus on what? That count alone. Right? Like this approach. We don't want to focus on all combination like that. We only focus on what? Count. So what is this approach? Math plus greedy approach. We are using what? A greedy solution. Fine. And sometimes the greedy fails. In that case, we will optimize that recursion or backtracking solution by using what? Dynamic programming. Fine. Thank you.